Welcome to my presentation. In this presentation, let us try to see some of the properties related to vectors. In here, let u, v, and w be three vectors and let c and d be scalars, be some constant terms. So let c and d be scalar quantities. Then the following things are true. Then the following properties are true. 1. If we have vector u, if we take vector u and then add it to another vector v, whether we add it this way or whether we add it this way, the result is going to be the same. But if we take vector v and add it to vector u, or take vector u and add it to vector v, it is going to be the same. This is what is called the commutative property of addition. The second property of vectors is if we have three vectors, vector u plus vector v plus vector w, and no matter which way we combine them, the value is going to be the same. The value is going to be the same. We'll pick some simple examples to show you how that is done. For some reason, if we want to combine vector u and vector v first and then combine it and then add vector w to it, or if we were to combine vector v and vector w first and then combine it to vector u, the result is going to be the same. This is very similar to some of the properties which we have seen in basic algebra, and this is the associative property of addition. The third property of vectors is if we have vector u and if we were to add it to another vector which has 0 components in there, it is not going to change the value of the original vector. It is still going to be the same original vector u. Then, if we have a vector u and if we were to add a vector which is equal to but opposite in sign, the value is going to go to 0. It is going to produce a 0 vector. Okay. Then, if we have a constant term c, which is a scalar quantity, which we normally call as a scalar quantity, and if we were to distribute it to a vector u plus vector v, which is inside the parenthesis, we can write this one out as the constant times the vector u plus the constant times the vector v. This is very similar to the distribution property we have seen in basic algebra. Some of the basic algebra properties still hold good for vectors as well. Okay, so we will use these properties and solve some simple example problems in my next presentation.